In this tutorial, we're going to be going over Kangaroo 2, and we're going to be playing around with a tensile structure. And so, Kangaroo 2 is a plugin for Grasshopper, comes in there. And for to start with, we're going to be using the example file provided by Daniel Piker on his GitHub. If you type in GitHub Daniel Piker Kangaroo examples, you'll be able to get the same file that we're starting out with here. If I turn the preview on and go into the perspective view here, we look around, you can see we've got this kind of fun tensile, simple tensile structure. And so the first thing we're going to do is, I think it's more fun to see a different form of this solver. So we'll go up into our tools, we'll click on Kangaroo 2, and under main, there's a Bouncy solver. And this solver is more similar to Kangaroo 1, where it actually shows us more of the iterations that are going through the solver. Instead of just giving us the output, we can kind of see how it's working on that solver. So we'll just take our goal objects. If I hold Control and Shift, I can grab all of those at once, and I'll plug those in. We can see it's unhappy because we have to reset the solver here. So I'll make a button and I'll put it into reset and I'll click that button. Now we can see our solver is bouncy, and it is a little bit more fun to play with. And the whole point of this is that we're playing with playing with physics. I want to be more in the mode of playful exploration than hard exploration. So this is going to suit my needs a little bit better. So what we want to do is we want to take kind of this simple version and let's make something a little bit more complex that we can play around with and have a little bit more fun with it. So my thought was, let's make something a little bit more like Fry Auto's kind of pavilion, where we have kind of a radial form with some verticals. Looks a little bit more like a tent structure. And in order to do that, I'm going to make some Rhino geometry. So I'm going to come into my surface. I'm going to click on the little sneaky button here. I'm just going to make a rectangular surface, rectangular 2-point surface. I'm going to do something maybe like that. I'll click on this surface and hit F10 to show my control points. And I'll select both of those control points by holding down Shift while I select them. I'm just going to scale this in to make kind of one of my petals. And then I think I'm going to shorten this up a little bit, maybe something kind of like that. Great. I'm going to hit F11 to hide my control points. And I'll come in here and I just kind of want to array this around a little bit. To do that rather quickly, I'm going to type in mirror. And I have my snaps turned on and my points, so I'll grab this end and I'm just going to mirror it about its edges on either side. So now I have this a little bit more radial form here, and what I'm going to do is create a new mesh that I can then swap out this original mesh for and use the kind of same operations that are going on in Kangaroo over here. So the way that Kangaroo is working is we have our engine or our solver, which we can find under main. There's a few different flavors of this solver, along with some a little bit other fun things that we'll get into as well in this tutorial. But then we have goals. So in the simple one, what we have are some anchor points that are constraining our mesh. And then we have our mesh, and what we're trying to do is make that mesh edge length smaller so that it acts like a tensile structure. And we can play with that length factor. The closer we get to 1, the more it just behaves like a simple cloth. And the tighter we make it, the kind of more it behaves like a um, maybe like a nylon membrane or something a little more elastic, uh, which is quite fun. So what we'll have to do first is reference this geometry into Grasshopper and start building up our base so that we can swap these out. So what I'll do is I'll just hold the Alt key and click, give myself a little bit more room. And I'm going to make a surface container here. And I'm going to reference in those surfaces by saying set multiple surfaces, selecting these surfaces. I hit enter. Now they're into Grasshopper. So the next thing I want to do is I want to convert these to meshes. So I'll come over into my mesh tab and I'll go to utilities and I'll say mesh surface. And I can bring in my surface here and I want to change my U and my V count so that I can see the kind of internal lines of these meshes, which is what is actually working in Kangaroo. Each one of these little bit of lines acts similar to like a spring force, and then all of these springs work together to create our kind of network of springs, which gives us our tensile membrane, if that's a good word for it. And so in order to be able to see these kind of internal lines, what I'll do is I'll go under the Mesh tab, under Analysis, I'll go to my Mesh Edges, and I'll just drag this up. So you can see here this is much coarser than what I want to get a kind of a relaxed shape. So I'm going to change my U and my V count. In order to do that, I'm going to make a couple of number sliders. So just double click on my canvas and type in a number. I'm using 12 because it gives me a number between 100 and 0, which I think is quite nice. And doesn't really matter too much. I'm going to copy that down, Control C and Control V to copy that. And I'll plug those both in. I'm just going to adjust these a little bit so that they look a little bit nicer, a little more uniform. I think that should be good enough for our purposes. Okay. Another thing to note, if I'm just going to hide this, we can see we're getting different colors for our meshes. In some ways that can be distracting, in some ways that can be kind of detrimental. I don't think it'll have an effect on our solution here, but just to make sure everything's uniform, what happened was when I mirrored across this plane, it like if you were flipping a pancake, um, these normals are upside down compared to these ones. So an easy way to fix that, I'll select the surface in Rhino and I'll type in flip as a Rhino command, and I'll flip that surface and I'll do the same thing over here. So now they all point up the same direction and we should be okay. I'm also going to change this one maybe to 12, and maybe I'll change this one to 12 too, just to kind of keep things coarse at first. So now I have my base mesh in here, and I'm just going to make a mesh container to hold this so that I know what stuff I'm going to be replacing. So I'm just going to quickly replace this mesh in here and this mesh over here. Before I get too far, I'm going to I'm going to open up bifocals, which is an add-in that allows me to see both the icon and the mesh and the node name at the same time. And hopefully this will help with this tutorial a little bit. The other thing that I've done is I've said draw full names in here so that we can see all of the inputs as kind of real text instead of over here where we just have BWH. You can hover over this and see what that input is asking for and what's stored inside of it. But I think for the sake of this, it's just a little bit easier to understand. So what I'll do is I'll take my mesh and I'll plug that in. We can see we don't get much changes because our anchor points over here are a little bit different. And so I'm going to actually swap this out. So again, we have goals over here. So what I'm going to do is I'm going to go to my goals PT for my points. I'm going to bring out the anchor tool, and now I just have a little bit different kind of visual there. This is by default Daniel Piker's script. Didn't have this turned on, so I changed it. So what I'm going to do is just swap these out. And I'm also going to change out this mesh corners as well. You can find this. So I want just these corners here. We're seeing this is working. It's getting just these kind of hard corners for each one of these meshes. In order to do that, I go over to my mesh tab. I go down to mesh corners, and I can pull that out. So I can delete both of these, and I'll bring in this mesh to get my mesh corners. I'll bring these in to my anchors, and then I'll also add this goal into my solver, and now we can see we're getting a surface, um, a tensile surface using these anchors as their points. One thing to note, I'll hit refresh just to kind of clear out this extra stuff, and I'll delete our base mesh as well and hit refresh again. So the next point is that we have these kind of target anchors. So what we can do is we can set up a couple of targets for how we want to move these anchors. However, for this example, what I want to do is I'm going to leave these ones kind of the current anchors that we're seeing right here. I want these to be flat, and I want to put up some like vertical anchors in the middle so that we have a little bit more of like a tent-like structure. So I'm just going to clear this out. I don't think we're going to be needing it. One note with this length factor, I was playing with it earlier. We're just changing it from 1 where it's not being tightened, and then we can kind of tighten that in and make it a little more tensile, so to speak. So the next thing I want to do is I want to define these other anchor points. So what I'll do in Grasshopper, I'll just double click and I'll type point, and I'll be able to get a point container. I can also get that same thing from going over to params, geometry, and point. And then if I right click on this and I say set multiple points, and I'm just going to choose these midpoints for now. And I'm going to say, let me step back here just 1 second. So I want these to be anchor points, but I want to be able to move them around a little bit. So I'm just going to add these in. And then if I start to move them, we'll see we start to get some weird behavior, and it doesn't quite work the way we want to. So, I accidentally hit Control Z in Rhino instead of Grasshopper. So I want to disconnect this. And what I'm going to do is I'm going to take these corners and these points, and I'm going to open up a merge node. So I'm going to merge this data together because I want to be able to keep track of that data list hierarchy. So I can bring those into my list of points, and I want to take, I'm actually going to reset this. So I'm going to say set multiple points, midpoint, midpoint, restart. Oh, it just gave me 1. So I'm going to clear these values and just restart from this beginning. Set multiple points, set the middle, right click. Oh, it's not wanting to do that for me. So clear values, there we go. Okay, don't have any of those midpoints. Then just hit reset over here. Then I'll right click, say set multiple points, come back to my midpoint, bring it over here, and if I just right click, it'll instance those in. And so now what I want to do is I want to be able to set my targets to be a little bit different. So what I'm going to do is I'm just going to copy these 2 elements down, since we're going to leave our corners where they're at to be anchored along the mesh, we don't have to put in a new parameter there. We can just leave our new input there. We can just leave our mesh corners. And what I'll do is I'll bring this up to the targets. So now I can take my target and I can move this up and move this up. If I kind of spin around, you see we're starting to get more of our tent structure. That's all great, except for if I take this point, no, that works as intended. Oops, keep flipping that. But if I take this point down here and I move it, and it's not perfectly on the intersection of our mesh edges here, it breaks. So we're going to imply, or we're going to use a little bit of logic here so that that does not happen. And the way to do that is what we'll do is we'll take our meshes and we'll get all of those intersection points, and then we'll find the closest point of those intersections to the point that we're moving. So it'll always kind of snap to the nearest intersection. So it'll fix that problem for us. So what we'll do is we'll take this base mesh. What we want to do is we want to find all of the intersections between those. So we can either deconstruct all of these mesh faces, or if we come over into Kangaroo 2 and we go under Mesh, we have this Naked Vertices tool, and we can grab that. Another tool we could use is, we're going to use Naked Vertices. So we'll take our base mesh here, and actually we could take it from our input. And what we're going to do is, you can see it gets both the naked vertices and the clothed vertices, which is what we want. So what we'll do is we'll take the closest point, if I could spell closest point here, and the point we want to use is our anchors over here. So there's our points that we're going to use, these ones. So if we move them, these are kind of the ones that the closest point is acting on. And then our cloud of points, we're going to bring in both the clothed points and the naked points, and we'll just flatten that all down so it's in one nice closed list. So now, if we're looking at our points here, if I grab this and I start to move it around, it's going to be still finding that closest point, right? So you can see it's searching through those intersections. It's a little bit confusing to see since I have this turned on. If I turn this off, it might make a little bit more sense. So just grab both of these, and you can see that green point starting to travel around to these intersections. And that's what Kangaroo wants. It wants to have our anchors be on an kind of like a vertex of the mesh. So we're good to go there. The next thing I want to do is, because I had moved the target points upwards, what I'm going to do is I'm just going to say move, and I'll take these closest points, and I'll move those upwards in the Z direction for my motion. And then I'm just going to plug in a number slider for how high to move that. I'm going to use just a number slider in here. So now I can move these around. And if I plug that, I'm going to swap out these original points. I'm going to bring that in instead. And so now what I have, let me turn this back on. I'm going to hit reset. And something is not working. So I should have 2 points coming out of there. Yes. And I have this base point as an anchor. Oh, I actually have to swap this one out as well. So now I can get rid of these or I'm not going to get rid of these because I want to be able to move them around. But now everything is actually being controlled by this closest point instead of these points that aren't actually on the vertex. So now if I start to move that around, we can see it changes the location of what I would call like maybe my tent pole in kind of a nice way. So I can take all of this. This logic is pretty good. And I'm just going to hit Control G to group this, just so I know kind of what's going on in here. Could label this as well, which might be nicer down the road. But for now, I have kind of a really nice logic of how my anchor points are working. Maybe the next step is that I actually want to be able to see the surface of this mesh as well, coming out of this output. And that's where we're going to get into kind of these some fun parts of this other main tab under Kangaroo 2 tab. We're going to go under main and we're going to say show. And this is a goal. We want to show this base mesh. But if I plug this in just as a goal now, we'll see I get the desired result. But the problem is on the output, everything's just kind of jumbled together. So it's hard for me to separate just that mesh. So what I'm going to say, I'm going to open up an entwine node here, and I'm going to entwine. The first branch will be my show command, and my second branch will be the rest of my goals. So I'm just going to bring that in and hold shift to add that into the list. I can actually just minimize this down and then I'll replace all of my goal objects here. So what that's doing is it's saying the very first thing that's going in at this branch 00 is going to be that mesh that I want to see. And then the second thing that's going in are all of my goals. So if I look at my outputs, I can see I'm getting my meshes first and then the other objects second. So one of the other problems that I'm seeing is I'm getting some weird seaming happening here. And that's because all of I'm actually running this on 3 different meshes instead of one unified mesh. And unifying those meshes is a little bit of some tricky behavior. They're not going to want to join or weld in the proper way, and I can show you what I mean there. So if I say join meshes, mesh join, and I bring this in, I'm going to get some weird behaviors. I'm just going to swap that out. And it's actually still keeping those seams. So it's not doing exactly what I wanted it to. I can hit reset here, and I'm still getting kind of some weird seaming issues. So what I'm going to do is I'm actually going to leave them joined because it's giving me one mesh. And what I'll do in my mesh tools and in under triangulation, there's a quad remesh tool. And I'll bring that in. And to see the difference, I'm going to actually change out my mesh wires. And now I have a little bit different mesh here, but we can see it's all unified. And it does some kind of weird squiggly stuff, and that's okay. It's trying to find a best fit mesh through our kind of funky shape we have going on here. There are other ways to do this. In the sake of this tutorial, I'm using Rhino 7. Rhino 8 is out, but most of the people who are going to be watching this are using Rhino 7. And then also there are some additional add-ins like Weaverbird that have a little bit more elegant solutions to joining these meshes together, but we're not going to really get into mesh topology for the sake of this tutorial. So now if we bring that in, we see we're getting rid of that issue. And what I'm going to do is I'm going to just bring these over. I'm going to hide this so that it's not so distracting. I'm going to click on reset. And I'm actually going to hide all of my anchor point logic too, so it's just a little bit cleaner for me. Um, and I'm having some issues with these anchor points on the outside now. So if I click on my mesh corners, I'm not getting all of my corners. I'm just getting kind of these 4 corner points. And a way we can change that is the angle for those mesh corners. And if we look at what the description is, it's pretty much an angle of which corner is defined. Because we use the quad remesh, we're getting a little bit different, let me show that. We're getting a little bit different kind of an angle condition at these seams. One way to do that is I could actually, let me zoom out, sorry. I could either increase this just a tiny bit. Oh, it's not changing it for my quad remesh, and now I've exploded Kangaroo. Yeehaw. If I hit reset here, it'll go back to my shape. Um, First, I'm just going to change this angle. Our initial angle is 2.35, so I'm going to say maybe 2.35 as an input. We'll put that in, and if I just bring that down a little bit, I should, ooh, maybe I have to bring it up a little bit. There we go. Now it's finding the rest of my corners here, which is what I wanted. Great. And the other thing I can do on this output, because now I have the first line item is my mesh on here, thanks to the entwine, I can just say list item, and by default that index is 0, so it's getting the first item, and you can see I have now my mesh, and I can say mesh just to verify that, and I have a little mesh container, and it's not giving me any complaints there. So now I can actually turn off those other kind of strings and points, and I can see what I'm getting. Might even come even further back and hide a couple of these other things, so it's just a little bit cleaner and a little bit more visible. So now I have a pretty clean solution. This all looks very smooth. I'm not getting the same kind of seams that I was earlier. I can change how much that mesh is relaxing and not relaxing. And I can also come in here and grab my points. And I accidentally turned that off. So let me unhide those, and I can bring these around. I can start to see how that is responding. So in the case of this, it's actually working quite nice. Um, there are some issues and some slight discrepancies, but for the sake of this tutorial, again, we're not going to get too far into like mesh topologies and remeshing and things like that too much. Besides that, using just that base quad remesh. What we're going to be doing is we're going to be adding some poles into this tensile structure so that we have something representative of where those would be. This is an imperfect solution in that it is a resultant of our mesh. However, it is not working perfectly as it would be in a perfect kind of net zero equilibrium solution. And so I would call this like pseudo tent poles, if you will, and we'll get into that. So the way that we're going to do this, we're going to take these top points because those are the tops of our poles. And to do that, I'm just going to make a point to try to keep everything clean. One thing I will add is that this solution looks a little bit different at this point. I've just done a little bit of cleanup to kind of remove some of the crossing spaghetti lines. This group down here is allowing us to move our points. We went over that in the last tutorial here. But with that, what I'm going to do is I'm going to take this move geometry and grab these top points. Again, these are our target anchors. We're using the same thing here. And so I'm going to bring that over. And the next thing I want to do is grab all the vertices out of the solution from our mesh. So I'm just going to copy this point up, and I'll grab these vertices, and I can see all of the different points on here. And what I want to do is I want to actually average out these points and find something on the base that's kind of an average of this tightened mesh network. So in order to do that, I'm going to say closest, if I could spell, closest points. And for the point that I want to find the closest points to, I'm going to put in our top points here. And then for the cloud, I'm going to put in all of these points down here. And then for the count, I'm not sure how many we're going to find, so I'm going to make a number slider between 0 and maybe 2,000. Seems like a lot now, but we'll see how that works in a bit. So it's mad because I have 0, so it can't find 0 points. But as I increase this, we can see we're kind of finding these averages here. It was kind of fun. So we're finding the closest points within there. Maybe we'll leave it about there. Won't find these extremes. Maybe that matters. Maybe it doesn't. Yeah, let's just bump it up till we have all the points. There we go. So I'm going to take these closest points, and I'm going to back into our list logic because I've provided it 2 values here and 1 point cloud. It's going to give me 2 branches of my data, and so which is perfect because I want to be able to analyze each of these independently. So what I'll do is I'll deconstruct these points, and then what I want to do is find the average of the x and the y's. So I'll say average, and I'll copy that down to get the averages of the y. So now the average of the x and the y, and I'll construct a new point. And I'll use these averages as my x and my y, and I want my z to be 0 because I want it to be on the ground. And based on our geometry, these are very close to each other, and that's okay for now. But our z coordinate is 0, since that's the base plane for all of our other anchors and where the rest of this is working out. So then what I want to do is I want to draw a line between our base points and our top points. And so I'll just type in line, and I'll do a line 2 point, and I'll have my start be these bases. Well, maybe I'll have my end be these bases, and then my start point will be the tops from the beginning. And I'll just move this down so we're not getting too much spaghetti tangled up here. And now, one of the issues that I'm having is I now have 2 branches of this data set, and I have a single list or a single branch up here. So if I just graphed this, now my output is going to be 2 different lines. I can see that kind of represented if I zoom in. I have my 2 lines there. So lastly, what I might do is I will extend extend the curve, extend these lines, and I'll extend this curve. And for my start, I want that to be 0, so I'll type in a double slash, and I'll type in 0. It'll give me a panel with that 0 in there. Put that in my start. And my end, I don't know how long I want that to be, so I'll just type in 12 for now. Oh, and that's going out the bottom, so I have these flipped. So I'm going to just swap these out. And now I have my kind of pole ends here. I'm just going to bring these in a little bit, maybe something like that. And then let's pipe them. Since there's only 2 lines, this isn't going to be super computational heavy. Oh, and those are way too thick. So I'm going to just reduce my radius. Type in maybe 0.55. We'll see what that looks like. It's still a little bit too thick. I'll just dial that in a little bit. Okay, so now I have my 2 tent poles, and they seem like they're doing okay. And this is where it becomes a little bit of like pseudo magic, because the less of the averages that I get, the less extreme they become. So the less points that I'm averaging, the kind of less extreme that these tent poles become. And this is where, again, this is an imperfect solution. It's just to be representative. I do think averaging all of them is kind of the best solution. But the fun part is now I can come back into where my anchor points are and move these and see that it starts to kind of change my locations of these poles. Maybe I'll just adjust that a little bit. So the more kind of tension that comes into this point, the more extreme the bias will become for its location. So we can see that here. Like this pole is very, very tilted. If I move this one closer to the center, it becomes, less extreme of a curve because there's a lot of things acting on it. Again, this is imperfect, so these 2 poles aren't acting, they're not aware of each other so much. But in some ways they kind of are, because we're averaging all of the points. So it's not, again, it's not perfect, but it's getting something for us. And it's not totally out of skew, but it's not, again, it's not perfect. So, again, we're just having fun with this. We're trying to get like a concept sketch out. We're not trying to actually engineer everything. We're not providing a finalized solution. But I think that this is a pretty easy way without having to get too far into setting up your Kangaroo file to be more heavy and putting in a bunch more goals to be able to solve these polls as they maybe should be, and maybe Daniel Piker would disagree with me here. And actually, in the comments, if anyone has a different solution or a better way to do this, please let me know. I'd love to hear about it. But I think this is a pretty simple way to do something that is representative of what we're trying to accomplish as a whole within in the solution. One thing I might do is I'll come over here and I'll hide a couple of these points, and now I have my tensile structure with like a pseudo pole, and if I hit kind of resolve, we can see those tent poles are moving in accordance with our structure. So they're pseudo responsive, pseudo structural, but again, kind of a fun way to do it rather than just sitting here and trying to draw something that maybe is less complete to your, or less responsive to your solution. So just some fun. Hope everyone enjoyed this, and hopefully this helps you with your projects. So with that, I'll see you in the next tutorial. Cheers.